So let's talk about a heating curve. On this axis, we'll have the temperature in degrees C. So here's 0 and here's 100. Water freezes at 0 and boils at 100. On this side, we'll put heat added. So we start with ice, and we start with ice at minus 10 degrees, so it's here. And we add heat, we find that the temperature increases. But if we continue to add heat and we hit this 0 mark, 0 degrees, we find that the curve flattens and the temperature no longer increases for a period of time. We keep adding heat, we'll see that the temperature once again starts to increase. It increases until we get to 100 degrees C, and there again it flattens out and then continues to increase. So what's happening here? Down here at the very on the left, we're starting with ice. So if I take ice and I apply heat, the temperature increases. When it gets to 0 degrees, the ice begins to melt. And as the ice melts, all the energy that I'm adding when I'm adding heat is going into melting the ice, not into increasing the temperature. So the energy here, the temperature flattens out because the energy is going into melting the ice. Once all the ice is melted, we have liquid water. And if I add heat to liquid water, the temperature increases. But when we get to 100 degrees, the liquid water begins to vaporize or boil. And all the energy, I continually add more heat, add more energy to the system, but instead of increasing the temperature, it only increases the distance between the molecules. And so we get boiling. When all of the water has been vaporized, we get a gas. And if we continually add more heat, the temperature will increase. And that's the heating curve. You can go back the other direction. If you remove heat, your gas will condense to a liquid, and then from a liquid it'll freeze and make ice. But you get these plateaus where the energy, instead of changing the temperature, is going into breaking the bonds between the molecules and freezing or melting, boiling, or condensing.